We continue with section 9B, linear modeling. We'll do pages 4 and 5 in this video. A linear model is nothing but a linear function. So we have the linear function, the straight line equation, y equals mx plus b. So that's exactly what this equation is in your book. The dependent variable, so that's your dependent variable y, so that's dependent. And we can switch these two, since that's an addition sign, we can switch the two. So that's mx, m is the slope, and x is the independent variable. So this is the term, rate of change times independent variable is the term mx plus the initial value, which is the y-intercept. So the equation is just y equals mx plus b. It's just written a little differently in the form of word descriptions rather than a mathematical description. So the initial value, that is just the initial value. So b is the initial value plus slope or the rate of change times the independent variable equals the dependent variable. So if you remember the equation y equals mx plus b, this is exactly the same thing. So let's look at the first equation. The world record time in a 100-meter butterfly, that is swimming, was 50.40 seconds in 2006. The record falls at a constant rate of 0.05 seconds per year, which means that people are swimming faster and faster every single year by just slightly. It's not like it doesn't increase by, or their speed doesn't increase by that much, but still it is faster. So as time increases, the completion time for a 100-meter butterfly is decreasing, even if it's very slightly. So the rate is given to us. It's 0.05 seconds per year. And remember that it falls. So be careful with the signs. When you write down your rate, this is important. Since the time, the record falls at that rate, which means the time is decreasing at the rate. So that would have to be a negative 0.05 seconds per year. That's how we describe the rate in this case. What does the model predict for the record in 2020? So what do we know so far? We know the initial value, so that it's the beginning of time, 2006. It's 50.4 seconds. The rate is given to us, and we want to know what the time is in 14 years. So how did we get 14? 2020 minus, so that's a 2. 2020 minus 2006 is equal to 14 years. So 2006 corresponds to time or independent variable 0, and 2020 corresponds to t equals 14. So we know the independent variable, we know the rate, we know the initial value, and we're trying to predict the record in 2020. So the dependent variable is the record in 2020. You plug in all the numbers into the equation. Y equals, so that is your y equals mx plus b. Just remember that it's exactly the same thing. So plugging in the numbers, we get 49.7 seconds. So the record improves quite a bit in 2020 as compared to 2006. Now the next question It's the cost of leasing a car, and let's see what it says. The cost of leasing a car is $800 for a down payment. The, and the processing fee and the down payment come up to $800. Plus, you're going to have $240 per month. So it's $800 plus 240 per month. That's going to be your cost of leasing this car. So we can take the initial value to be 800. The rate of change would be $240 per month. And the question says, for how many months can you lease a car with $3,680? So if your total bill comes up to $3,680, how many months were you able to lease the car? So the amount that we pay, so that's your Y, depends on the number of months that we can lease the car, and that is X. So the dependent variable is the amount paid. The independent variable is the number of months that we lease the car. Setting up this equation, y equals mx plus b, the rate is 240. X is the independent variable. We don't know what it is. The number of months that we're going to lease it, that is your dependent variable. We have a total of $3,680. Solving for x in this equation, x is the only unknown. We first subtract 800 from both sides. That's how it goes always. Subtract 800. And then finally, we're left with 240x equals 3,680 minus 800. Now to get rid of the 240, we divide both sides by 240. So it's 3680 minus 800 in parentheses divided by 240, and that gives us 12 months. So with a down payment and processing fee of $800 plus an additional $240 a month, we can lease the car for 12 months if we can afford $3,680. Now, the next part of the question, in 1980, that is at the beginning of time, the population began increasing at a rate of 200 people per year. So the rate is 200 people per year. The 1980 population was 2,000 people. So at the beginning of time, the initial value of the population was 2,000 people. What is your projection for the population in the year 2010? So if the year 2000 is equal to, it corresponds to time t equals 0, then the year 2010 corresponds to t equals 10. So the time t equals 10 years. What's the population, which means what is the dependent variable? It's clear that the population depends on time. So the number of people depends on the number of years that have gone by since 2000. So the dependent variable is the population and the independent variable is the time. So we write down the equation, y equals b plus mx. It's the same as y equals mx plus b. Plugging in the numbers, the independent variable is 10 because that's 10 years. 200 is the rate plus an initial value of 2,000. There's going to be 4,000 people in the year 2010, and clearly the population has doubled in 10 years.